Hello, my name is Syed Muzammil Hassan. I have been teaching mathematics to the students of secondary classes for the last 10 years. So I'll solve some question here. Question number 1. From the top of a 7-meter high building, the angle of elevation of the top of the tower is 60 degree and the angle of depression of the foot of the tower is 30 degree. Find the height of the tower. So first of all, we will draw the figure as per the given question. Suppose this is the building, this is 7 meter, and let this be the tower. So as per question, we have to show the angles of elevations and depressions. To show the angle of elevation and depression, we need a horizontal line. Let AB be the building and CD is the tower. So here this angle is 60 degree and the angle of depression of the foot of the tower, that is point C, from the top of the building, that is from point A, is 30 degree. This is 30 degree. Now this is 7 meter, so this CE will also be 7 meter. Now if we suppose the height of the tower as h, then this distance DE will be h minus 7. To find the height of the tower, that is CD, first of all we will find BC and then we will get the value of AE. So using triangle, in triangle ABC we have tan 30 degree, because this angle is also 30 as per alternate interior angle theorem. Tan 30 degree is equal to AB by BC. So here the value of tan 30 is 1 by under root 3 and the value of AE already given, that is 7 meter, by BC. So we have to find the BC. The value of BC comes out to be 7 under root 3 meter. Right? Now from the figure we can say that AE and BC are equal. So the value of AE should be 7 under root 3 meter. Now we will again take the triangle AED. In triangle AED we have tan 60 degree equals DE by AE as per P by V. So the value of tan 60 is under root 3 equals D we have to find, and that is given h minus 7 here, and AE is, we have already got, 7 under root 3. So if we solve this, we get 7 under root 3 into under root 3. So h will ultimately be 21 plus 7, that is 28 meter. Hope this answers the question. Now move to the next question. The question says, a toy is in the form of a hemisphere surmounted by a right circular cone of the same base radius as that of the hemisphere. If the radius of the base of the cone is 21 centimeter and its volume is 2 by 3 of the volume of the hemisphere, calculate the height of the cone and also calculate the surface area of the toy. So in the same way, first of all we will draw the figure. Let us see how will be the figure. Here it is. Suppose I take this triangle to draw our cone. Suppose this is the cone, and now we are going to draw the hemisphere. So this is the toy, which is the combination of a cone and a hemisphere. This is the radius of the cone as well as the hemisphere, and we have to find the height, and that is h. This is the h. Here it is r. So the value of r is already been given, and this is 21 centimeter as per the question. Now, as per the question, we have to take the volume of cone. Volume of cone is equal to 2 by 3 of the volume of hemisphere, right? So we already know the volume of cone is 1 by 3 pi r square h, and the formula for the volume of hemisphere is 2 by 3 pi r cube. So we are going to solve this to find h. So if we simplify this equation, what we are getting, this is 4 by 9 multiply pi r square into r. We will split r cube into r square and r, and by transposing this one pi r square and 1 by 3 pi r square, we are getting 3 by pi r square. Now it is easy to cancel out some part of the equation. So this is, so we are getting h is equal to 4 by 3, right, into r. So what is the value? 4 by 3 multiply 21, this is 7, so we get 28 centimeter. This is the height of the cone, right? So I have already got height. Now we have to calculate the TSA of this toy. So for that purpose, we need to calculate the CSA of hemisphere and the CSA of cone. To calculate the CSA of a cone, we need L, that is slant height. So to find the slant height of the cone, we have to use this formula, h square plus r square. So what are the values? Values are 28 square plus 20, this is 21 square. So we are getting 784 plus, this is 441. What should be the sum? I think 1225, and we have got L is equal to 35 centimeter, right? Now come to the next page. So we got L is equal to 35. We have to find the TSA of the toy. Is equal to CSA of, that means curved surface area of cone plus curved surface area of hemisphere. These two surfaces make the TSA of the toy. So we have the datas. CSA of cone is pi RL, and the CSA of hemisphere is 2 pi r square. So for the calculation to be easy, we take pi r as common. So we are getting L plus 2r inside the bracket. This is 22 by 7. Now put all the values. So this will be 21. L we have got 35. plus 2 into 21. So these are the values. What we are getting now? Inside the bracket it is 35 plus 42. Now cancel out these 3. So we are getting 66 multiply 77, and so the answer is 5082 centimeter square. Hope this answered the question. Come to the next question, and the next question is about to solve trigonometrical identity. We have to prove the identity. So what is that? The question is tan A upon 1 minus cot A plus cot A upon 1 minus tan A should give 1 plus tan A plus cot A. So this is the identity. First of all, we will convert the LHS into sine and cos. 1 minus cos A by sine A here, plus this cot A will become cos A upon sine A by 1 minus sine A by cos A, because tan A is equal to sine A by cos A and cot A is equal to cos A by sine A. Now let us simplify this. Sine A by cos A, and this will become, if we take the LCM, we are getting sine A minus cos A in this place, and here also the same thing will be copied, cos A by sine A upon cos A minus sine A, and this is cos A. So now further simplify it. Sine A upon cos A, it will become sine square A, right? And here we are getting sine A minus cos A, plus it will become cos square A upon cos A minus sine A, right? So now one step we have to take, that is we have to reverse this cos A minus sine A, we have to convert it into sine A minus cos A. In that case this plus will become minus as per rule. So this is sine square A by cos A, sine A minus cos A, and this will become minus, and this is cos square A upon cos A. This will also be reversed, sine A minus cos A. Now it becomes easy to take the LCM. So what should be the LCM here? So this is sine A, right, into cos A into sine A minus cos A. So we will see that ultimately it becomes sine cube A minus cos cube A. So we will convert this, the numerator sine cube A minus cos cube A, into the formula a cube minus b cube. So come to the next page. So it will become sine a minus cos a, that means a minus b, and it will be converted into sine square a plus cos square a square plus b square plus ab sine a into cos a. This is the conversion to the algebraic identity a cube minus b cube. And here we have sine a into cos a, and this is sine a minus cos a, right? So these two expressions are being cancelled here, and we are getting sine square a can be written like this: sine square a by sine a into cos a plus cos square a, again it is sine a into cos a, and ultimately here also sine a into cos a by sine a into cos a. So we are getting, if we cancel these, we are getting the answer. This is sine a by cos a, right, plus cos a by sine a plus 1. So we get tan a plus cot a plus 1, that is equal to RHS. Hope this answered the question.